What's poppin', dogs? Mr. Allen here with some rational functions and transformations of these bad boys. We got to determine the transformations, vertical asymptote and horizontal asymptote of each one of these functions given our parent function here, f of x equals 1 over x. So first one here, g of x equals 1 over x plus 5 minus 4. Well, the x plus 5 is in the function, so this is going to be a horizontal transformation. We're going to be going to the left 5. So we got left 5. Remember, on the inside, it is the opposite sign type of situation there, okay? It's about what's going to make that 0 in this case. And then the other one, we got down 4. So it's outside, so that's down 4. My vertical asymptote is always what's going to make my denominator 0, right? Make it undefined. Unless it cancels out, it's a whole, that's another thing, okay? So for my vertical asymptote, that's going to end up being x equals negative 5. Negative 5 would make that 0. That also kind of makes sense with like the left 5. The negative numbers are to the left. That's pretty dope. Okay. How about that horizontal asymptote? Well, without the 4, the minus 4 there, the denominator here, when the x values get infinitely larger or more infinitely negative, it's going to be getting really big in that denominator, whether positive or negative, and the 1 staying the same. So that means that if I take 1 and I divide it by an increasingly larger number, it's going to get smaller, 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 approach 0. Okay, so y equals 0 is the horizontal asymptote for this. But then, if I move it down 4, it's going to be y equals negative 4. So horizontal asymptote, y equals negative 4. Boom. Love it. Fantastic. So the x plus 5, that affected my vertical asymptote. This is shifting left, right? If I move left, right, that's going to change where my vertical asymptote is. If I move up, down, that's going to change where my horizontal asymptote is. Kind of weird to think about because vertical, horizontal, whatever, but it makes sense when you start thinking about it graphically. All right? Next one, h of x. We have 4 over x plus 1. Well, that 4 is going to be a vertical stretch. All right? So vertical stretch by 4. As I plug in my x values, like if I had 1 over x and I plugged in 1, I would just get 1. If I plug it in here, 4 over 1 is 4. It's 4 times larger, okay? If I plugged in if I plugged in 2 here, I'd get 1/2. If I plug it in here, 4 over 2 gives me 2. That's 4 times larger. So it's a vertical stretch by 4. And then over here, we got up 1 on the outside. So vertical asymptote. Vertical asymptote. What do we got here? Well, it did not shift left or right, so my vertical asymptote will not change. It's x equals 0, and we can also see that because when I plug 0 in for x, it's undefined, right? 4 divided by 0 cannot do that. Then we have plus 1. That's going to move the horizontal asymptote up 1. Initially, this is y equals 0 for the same reasons we talked about over here. As x gets infinitely larger, positive or negative, 4 divided by that infinitely larger number either side is going to get really, really small and approach 0, but never quite get there. So if I shift up y equals 0 up 1, I get y equals 1. So horizontal asymptote, y equals 1. Nice. All right, k of x. Let's see here. K of x. I'm going to go with pink now. We got negative 1 over x plus 2, and then plus 3. So that negative there, that's going to be a vertical reflection. So let's say vertical reflection. All right, or you can think of it as, we'll go vertical reflection, right? We could write that negative 1 out in front there. And then outside we have vertical. I think we'll stick with that. Really with these, depending on how you think of them, you can think of it as vertical or horizontal. It can tend to be the same thing, pending other transformations. But we'll go with vertical reflection here. Denominator. I'm going to the left 2. And then I'm going up 3. Nice. So what's going to change here? Well, again, whatever makes my denominator 0, that's going to give me my vertical asymptote, right? And that makes sense. I'm moving to the left 2. So we're going to have vertical asymptote x equals negative 2. I'm going up 3. Even though this is negative, even though I had the plus 2, that part is still approaching 0. If I shift that up 3, my horizontal asymptote will be y equals 3. Last one over here. Yellow, which kind of looks like green, but it's a little different. 3 over x. This seems like the simplest one here. We got a vertical stretch by 3, right? If I plugged in 1, instead of getting 1 over 1, I'd get 3 over 1. That's 3 times larger. If I plugged in 2, I get 1/2 here. I get 3 over 2 here. It's 3 times larger. So vertical stretch by 3. I don't shift left or right, so my vertical asymptote will be x equals 0. My horizontal asymptote didn't shift up or down. It's going to be y equals 0. As those x values get infinitely larger, 3 divided by an infinitely larger number is going to get really, really small and approach 0, but never quite get there. And that's a weird thing to think about with rationals, is that you're going to approach something, never quite get there. It's going to get really, really close. It's going to keep getting closer. No matter what, it's going to get closer, 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 but it can never quite get there. Crazy. But it's a wonderful world of mathematics. That's about it. I hope you guys have a fantastic day. Thanks for watching. See you later.